So now that we have fit our model with using both distance and change as predictor variables for the probability of a successful place kick, we're going to talk about how to do the confidence intervals for the betas as well as the odds ratios. Now first, these are very similar to the equations that we used before. So kind of refreshing our memory here on page 9 of the notes is where I can find those formulas. So looking here at the formulas on page 9, these are our formulas for our confidence interval for beta. And again, one of the main goals of doing that would be similar to do the hypothesis test to see if the variable is useful in predicting the probability of a successful place kick here. Probably of more interest to us is going to be the confidence interval for theta, which will then tell us how changing our explanatory variable may affect the odds of success. So these are going to be the same ideas that we're going to be working with. And one of the things that we need is that variance of beta hat. And if you recall, where we're going to get that variance of beta hat is coming from this variance covariance matrix that we used before, this cov.unscaled. It's going to look a little bit different though this time, because now I not only have an intercept and distance, I'm also going to have that change variable showing up as well. All right, so looking at how the code is going to look, let's actually first use some of this code in R just to sort of see what it looks like. So I've already fit my model. One of the things I'm going to actually do is also save the summary so that I can call things from it for myself. And then for right now, I am going to also just kind of look at that variance covariance matrix. So the first thing I'm going to do is add an additional line, mainly so I don't have to change some of my other code here. I'm going to actually save this summary of mod.fit into this thing called sum.mod.fit, so that's what I'm going to call it here later. So I just had to add an extra line here in my code. And again, I just want to look at this cov unscale. I'm not going to pull off the specific elements at the moment. So here is that little matrix that we had before, but now it's a little bit bigger. And our variances are going to be along the diagonals. And so this first one would be the variance of alpha hat. I'm not going to need that. This one here directly in the middle is going to be the variance of beta hat 1, or when I'm looking at distance. And the one here at the very bottom of this little matrix, bottom right, is going to be our estimated variance for the change beta hat. So notice that I have different estimates of the variance of the beta hats because it's a different variable that I'm working with. And so notice that this one is in the second row in the second column, and that this one is in the third row in the third column. So that's why you're going to see my code, when I'm doing the distance, is going to have the 2, 2. And then when I'm doing the change, I'm going to be pulling off the 3, 3 to get those corresponding elements here for me. Otherwise, the idea of the code is exactly what we had before when doing a confidence interval for the beta hats. Here I'm doing a 95% confidence interval. So here's my one for distance. Here is that estimate of beta. And then I have my confidence interval, which I can see does not include 0, which then shows me that distance seems to have this negative relationship going on with probability of a place kick. And I can do the same thing with my change variable. Again, there's my beta hat 2 that I had in my actual equation, and then its corresponding confidence interval. But again, those beta confidence intervals don't really give us the most useful interpretation simply because we don't have that linear relationship. So I can't actually have a true slope interpretation attached to these because it's not a linear relationship that's going on between them. Now again, maybe a little bit more useful will be those confidence intervals for the odds ratios. So going back and looking at that confidence interval here. Again, generally a good default is to just kind of assume that C is going to be 1, which would mean that we kind of get back to this confidence interval over here. If we did want to change the value of C and, for example, do a 10-yard increase or decrease in distance, I could change that accordingly as well, but the goal here is to do those confidence intervals here for me. And so if you'll notice what I'm actually, if I want to do that confidence interval, going back here, right, if I look at the confidence interval up here and then the one down here, E is just raised to this same thing that I have up here. So that's all I'm doing in the code, is then I can just take, well, oh, my lower odds ratio for distance will just be E to what this lower was up here. And then the upper will just be E raised to the upper up here. And this is, of course, assuming that C is staying as 1. If C was going to change to be something different than 1, I would have to change what I'm doing here for my confidence interval. And so here's my sample odds ratio, and then that confidence interval on it. And then doing the same thing, but now for the change. So now I'm using that third instead of the second value, because it was the third thing in my model, right? So change was the first, second, third element inside of here. So that's why that was changing here in my code. So now running those, we can get our odds ratio for the change variable. So they're just how we did it in the code aspect of it. But so now, what does this really mean for us? So we have these confidence intervals. How the first two can be useful for us, the ones about beta, is if I look at this one, it's all negative, or that is, it does not include 0. So it's really telling me then that distance is going to be useful in predicting the probability of a place kick, assuming change is also in the model. Now, where did I actually use change being in the model? Well, when I got this coefficient that had change in the model as well, when I got this variance of beta hat, it also assumed that change was in the model as well. Looking at the same idea for the change variable, this one is also all negative, or doesn't include 0, so telling us that change is also useful in predicting the probability of a place kick, even if distance is already in the model. Now let's look at our confidence intervals for our odds ratios. So first, remember our key number for an odds ratio is 1. You'll notice that neither of these confidence intervals includes 1. However, they're actually both less than 1. So this is where I'd actually like to invert it for interpretation purposes. So if I invert this confidence interval, take 1 over the endpoints, I get 1.101 to 1.137. And for the one down here, when I invert it, again, just taking 1 over the endpoints, I get 1.054 to 2.245. So let's actually interpret these. So for this first one, this was our distance. This was truly a quantitative variable. When we had it originally, what this meant we were doing was increasing distance by 1. Now that I've inverted it, we are now decreasing distance by 1. That's what inverting it's going to do to my interpretation. All right, so we are 95% confident that the odds of a successful place kick to unsuccessful, since those were our only options. Are between 1.101 and 1.137 times as large when distance decreases by 1 yard. Now, pausing here for a moment, does that part of the interpretation make sense to you? Why I'm doing distance decreasing by 1 yard. Right, my C was 1 because I didn't actually put anything extra in there to account for anything different. We're decreasing now because we end up having to invert that confidence interval. But this interpretation is not quite done. This would have been done before when there was no other variables in the model. But now we have that additional variable of change. So I still need to address it somehow. And so really the only way we're going to do is addressing it is by assuming change stays the same. Or in a sense, if I have that decrease in distance by 1 yard, whatever that change variable was isn't becoming a different value. So if it was going to be a non-lead change kick to begin with, it's still going to be a non-lead change kick. So I'm assuming that that type of kick, as far as the change variable is concerned, isn't changing as well. So if the only thing I do is decrease the distance by 1 yard, but that change thing stays exactly the same, here's how my odds of a successful place kick will change because of that. Okay, let's now talk through this change confidence interval. Because it was different, because it's a binary variable, so let's refresh our memory of what that's going to mean. When I looked at this, that was assuming you go from x equals 0 to x equal 1, or that x equals 1 was on the top. So now when I've inverted it, x equals 0 is actually the 1 on top. Now refreshing our memory here, if change was 0, that was a non-lead change kick. And if change was 1, that was a lead change kick. So let's talk through how that's going to be in my interpretation. So here we are 95% confident that the odds of a successful place kick are between 1.054 and 2.245 times as large for. Now, since this one's not quantitative, we're not going to increase or decrease something. We're just comparing the x equals 0 to the x equals 1. So it's this many times as large 4. On top, we have the x equals 0. So that's a non-lead change kick. And on the bottom is a lead change kick. Now, just as before, we also have to account for the distance. So this would be assuming distance stays the same. Or it's looking at, okay, as long as the distance stays the same, how does it being a lead change versus a non-lead change kick seem to affect my odds of a successful place kick? So the idea of the interpretation here is just like what we were seeing in previous videos, with the addition of this extra assuming part that we had to add to the interpretation. All right, the last type of interval that we talked about before was finding probabilities. So the good news here is they're actually a little bit, I wouldn't say easier than before. They're pretty much about the same, but there's not this additional thing that we have to account for, except for the fact that we have to take into account both distance and lead change at the same time. So before, we looked at distances of 20 and 50, and I'm going to do that as well here, but I'm going to do a distance of 20 for a lead change kick, and the distance of 20 for a non-lead change kick, the distance of 50 for a lead change kick, and the distance of 50 for a non-lead change kick. So notice how both of these have the same number of elements in them, and they're going to be kind of matched up of what I'm going to be predicting for. So I'm going to put that data just in a nice little data frame where, again, remember these variable names have to be the same as what they were called in the original data set that I'm working with. And we're going to use that data for our predict data. Remember, I'm using that link, so I have the nicer, the better way of doing my prediction. That way I can guarantee that my intervals will always be between 0 and 1. I'm getting that standard error, so I can actually construct the confidence interval. And you'll notice when I get these values that I have 4, because I have 1 for each of my combinations here of my types of kicks I have up here. So I have different fitted values as well as the standard errors of the fits. Putting these now in my confidence interval form. Again, if you need to see that formula, you can kind of go back here. This one I think is on page 10, yes, of how we did a confidence interval for the probability. So that's the formula that we're looking at. Now taking into account that we have 2 betas, not just beta hat, we have beta hat 1 and beta hat 2 that we're going to be using there as well. So that's where you're going to see that in my code as well. So for my linear predictor, I have my fitted value up here. And then we're going to do e to that over 1 plus e to that. So then I get my entire values here. I can see that linear predictor part, as well as once I did the e raised to it over 1 plus e raised to it. So I get all 4 confidence intervals here at the same time. So it's nice, I can compare if I have a 20-yard kick that results in a lead change. Here's my probability of success. Versus if it's a 20-yard, but there is no lead change involved, what that probability of success looks like instead. So I can take into account not only the distance here for my confidence interval, but also looking at if it's a lead change or not. So let's choose one of these intervals to interpret. You could interpret any of them. I'm just going to interpret the very last one here. So here I was using the same alpha that I had before, so we're going to be 95% confident. That the probability of this would be a 50-yard non-lead change kick being successful is between 47.96% and 63.58%. So it's accounting for both the distance as well if it was a lead change or non-lead change kick. So there's all of the intervals. Once we have multiple explanatory variables, we can have even more explanatory variables. So kind of a quick takeaway of when you first originally fit your model, pay attention to the order you list things in, because distance is now going to be the second element, change is going to be the third element. If I flipped these around when I actually entered them, change would become the second and distance would become the third. So the order you put things in up here is going to match the order they are down here. Which again, then those are important because it lets you know which coefficients you need to pull off for the one that you're interested in. So that's the place to be very careful with this, is making sure you're pulling off the right value. So really make sure that you're feeling good with kind of why 2s were used here and why 3s were used here. Feel good about why I inverted these and then how that changed my interpretations. And then finally, hopefully you feel okay with the predicted values here, as well as finding the confidence intervals for them. If you don't feel okay at this point, you need to stop and send me an email, come do a Zoom, let me know, because it's only going to get more complicated as we start adding even more variables to the model. So please email me with questions or set up a Zoom or just attend my Zoom office hours if you can wait till then. Because in the next video, we're going to talk about how to continue to add more explanatory variables, but talk about the method in which we will be doing so as well.